Now we discuss a very important concept, which is the cyclic prefix. Okay, the cyclic prefix is important in conserving the multi-carrier system. So if we do nothing, right, the system will fail. Why? Because the channel is frequency selective, meaning that the channel actually will perform linear convolution because it's frequency selective. It will uh, have an ISI component to it, meaning that the symbol will be spreading in the time domain due to the convolution of the channel, right? So even if the channel is known here, right, taking the DFT of a linearly convolved channel will not give you the multiplication that we are used to in the DSP material, right? Because this is a linear convolution. So in order to get multiplication in the frequency domain, this convolution must be circular. So this is the trick here, or this is the problem with that. Because when we talked about multicarrier systems, we said, okay, we can convert a wideband frequency selective fading into flat fading, right? We do that by dividing the bandwidth into subcarriers, right? So how do we do that? We talked about it and said, okay, we can use FDMs, but it's not very efficient, so we can use basis functions, which is very good. The way to implement basis functions is via the IFFT. Okay, the IFFT views every signal as a circular signal. So when you do convolution, you must do it in a circular manner. But the actual channel, the physical channel, is not circular. It's a linear channel. So the linear convolution will not be converted into multiplication. So we need a way to trick the channel into being circular, right? So what we do is that we take the symbol, right, and we take the last chunk of the symbol and we append it in the beginning. So the beginning and the end of the symbol look alike. So the channel will see the symbol as circular. So the linear convolution will be converted into cyclic convolution. And when we take the DFT of the cyclic convolution, it will give us the multiplication. So here we are converting the channel from wideband into flat fading. Flat fading channels, yes. Narrow band fading channels. So this is what we do. Okay. Now, how many symbols do we choose? It depends on the delay spread, right? So if we take TD, the delay spread, divided by TS, we'll get this value mu plus 1. So those symbols should be replicated. The mu plus 1 samples from the end of the symbol should be appended at the beginning of the symbol. Okay. So this is from a DSP point of view. What happens in the channel is that, okay, so here you have your symbol, right? It will go through the channel, right? And it will get spread, so it will leak here, right? So it will destroy this part of the adjacent symbol, but this part is actually redundant information. Okay, so this part is the same as this part here, so we don't care if this part get affected or destroyed, right? So we're just using it to perform circular convolution. So this is the trick here, is that we are employing a time guard. So this part, the cyclic prefix, actually it's a time guard that we don't care, so we don't leave it empty. We put redundant data into it to convert the channel from linear channel to circular channel, right? So this is the main idea. Of course, here we are not using this part efficiently from the power perspective, but we have to do it in this way.